Here is extremely important video for all those who want to understand the concept of domain and range in just 10 minutes. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have 8 examples to understand domain and range of some very important functions. These are the functions normally you see in the test papers, starting from grade 10 onwards. Question 1 relates to vertex form of parabola. Question 2 is a general equation for square root function. And then we have a rational function, general equation, which has ratio of 2 linear functions. Question 4 is again a rational function with x square minus p square in the denominator. Question 5 is sinusoidal function, trigonometric function, and then 6 is a very special equation for semicircle. Then we have an exponential and logarithmic functions. So mainly these are the functions required to master in pre-calculus, any courses which relates to functions or getting ready for calculus. As you can see, we have actually taken very general form of the equation. If you understand transformations with respect to these, then you can master the concepts. That's the whole idea. Perfect. Now, before getting there, let us just review what we learn in transformations. So generally, a function is transformed over the parent function normally, and we have few parameters. A times f and a outside relates to vertical stretches, compressions, and reflections. Now the k inside factor is relating to horizontal compressions, stretches, and reflections. These reflections are on y-axis. Perfect. And then we have the parameter p and q. P is p units translate right and q is translate up if both are positive. Perfect. So their meanings, very well known to you, are over here just for you to recall. We are going to use these concepts of transformations while writing domain and range. Now these are the graphs of the functions which we are considering. 8 of them are provided an extra graph here. Now, that is a composite function. So you can see parabola, square root function, reciprocal or rational function, trigonometric function, semicircle, exponential, logarithmic, and composition of functions. We'll discuss composition of functions in the next video. So I hope that gives you a lot of interesting things to come in this slightly longer video, since we are going to discuss all this here. Well, in case you want to learn from me, you can always send an email on the address given. My students are doing extremely well. Some of them are right there on the top of the class getting scholarships and awards like Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshit Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Okay, so let's begin with the very basic function, which is quadratic function. So here, when we talk about functions, we will relate to y equals to x square for quadratic function, and then see the transformations, right? You know the transformations for y, you know the domain and range for y equals to x square, and that helps you to relate with the transformed function, right? Now, in this graph, I have sketched the graph of y equals to x square right there, and another graph which is with some values which we'll discuss after understanding the transformations, correct? Perfect. Now, let's look into these parameters. A means a vertical stretch, and H and K are translations. Anything inside this bracket relates to horizontal, outside relates to vertical. That really means that if I have a coordinate point, let us say on y equals to x squared, the coordinate points are x and y. In that case, how will their image be? Well, the x values will be translated h units to the right, so we can write that the x value will be x plus h. As far as the y value is concerned, if the equation is a times this, they'll be multiplied by a and then we add k. You get the idea. So that is how the image points are going to be. Now they really help us to understand the transformations in general for all the functions. I'm explaining it here, but we'll move forward very quickly in the next 7 examples. Okay, perfect. So when you have this particular function, what does it give you? The vertex form really gives you the vertex. So in this case, the vertex is at hk. If I substitute h here, I get 0 and 0 plus k, the y value. Perfect, that's the vertex. For a parabola, this is a very critical point. It decides maximum or minimum. Perfect. Now, as far as the domain is concerned, you know, domain is all real numbers, right? No problems. So we can write x belongs to real numbers blindly for such general quadratic functions where no restriction is given in the question itself. Perfect. Now, let's look into the range. Range is tricky. Now, for range, we have to see what is the value of a. So, if a is greater than 0, means positive, in that case, the range is that the y values will be greater than and equal to the k values, since the parabola opens upwards in this case, right? However, it opens downwards if a is less than 0, right? So let me write down in a different ink what happens when a is less than 0. Well, if a is less than 0, in that case, y value will be less than equal to k. Perfect. So that is the basic concept, and so simple as that. Perfect. Now let's take an example. I'd like you to pause the video, answer this particular question. We have a function which is f of minus 2 times x plus 1 whole square plus 8. Can you please tell me domain and range for this particular function? Well, clearly, for the function which is f of x equals to minus 2 means it opens downwards, right? Perfect. And since it opens downwards, we have absolute maximum value, right? So the domain, as I was saying, will be all real numbers. And as far as the range is concerned, that means the y values will be less than equal to 8 in this case, right? Make sense? Perfect. And for your reference, I've given you the graph also here. This graph in red represents our equation. It helps to visualize. That is the key, right? And whatever we are doing, we are having an example so that you could relate to our learnings. Perfect. Now here is the second function, which is a radical function. So when I say a radical function, means y equals to square root of x, and in general, you can sketch this function like from here, right? So kind of like this, right? That will be the square root x function. Now we have a transform function here, which is, let me write it slightly bigger, f of x equals to a times square root of bx minus c plus d. Very important equation. Now, this is the most constrained function which we are dealing with. It's both domain and range are restricted. Now, how do you figure out about the domain part? Well, for domain, you should note that within square root, it has to be positive. Correct. That means bx minus c has to be greater than equal to 0. And that means that bx is greater than equal to c, and x is greater than equal to c by b. Perfect. So that is the combination x has to be greater than or equal to c by b, and that becomes the domain for this particular function. Perfect. Now let's look into range. So as far as the range is concerned, the minimum or a vertex or the starting point will always be at D. Now it depends on the value of A, whether it be greater than or it is going to be less than. So in such cases, we have two values, just as we had earlier done, right? So for D, let's write like this. If A is greater than 0, in that case, y will be greater than equal to D. And if A is less than 0, then y will be less than equal to D. Make sense? Perfect. So here is an example for you. I'd like you to pause the video and write domain range of this particular function. Now, it's kind of tricky, but go carefully about it, right? So let me rewrite this function here. F of x is given to us as 2 times within square root. We have half x minus 1, and then we have plus 1, correct? Now, you should always factor out this term, then you will get the right answer. Got it? So it will be 2 times square root of half factored out x minus 2. You get the idea, right? Plus 1. You see that? So what really happens is that the x and y values get transformed. So the x value and the y value on the original function, it was xy. Then on the transformed function, the x values get multiplied by 2, and that is the effect of half here. It means horizontally stretched by a factor of 2, right? So x and then plus 2 on the right hand side, y values will get multiplied by 2, and then we are going to add 1. That is going to be the transformation of the points. So if you do this transformation of the points on the given function, that is what you're going to get. You get the idea. So what I've also done for reference of some students, they could check different values of x and y, right? For example, 0, 0 and 1, 1 are the points on x, y, and their corresponding points are shown on the transformed graph, just to verify. This exercise is not only to teach you domain range, but to give you a full idea of how to work with functions, their transformations, and relate similar questions, and give you tips. For example, here, very important, we have to factor out half, otherwise you do not get this 2 inside, and all your answers will be wrong. Right. So now we can write down very clearly what the domain and range is going to be. We will, for this particular function, say x belongs to real numbers. However, x has to be greater than equal to, since it has moved 2 units to the right, right? Greater than equal to 2. Correct? As far as the range is concerned, the y values, that is, so whenever I write y, it means range. Perfect. So it has to be greater than equal to the translated 1, right? Translated up by 1. So you see, translation is the key here. Another key feature which you learned just now is when you get this function in that form, you need to factor b, right? So you should write this function f of x as what? A times factor out b, then you get x minus c over b, right? Plus d. Do you see that? So this c over b, when you factor, is the straight answer. Does it make sense to you? That's a key while you're working with the functions, transformations, and their domain and range. Perfect. So I hope this is absolutely clear. In case you want to learn more, you can always send an email on the address given. Perfect. Let's move on to the next type of function, which is a rational function. Now this is a rational function which is quotient of two linear functions, ax plus b and cx plus d. Now in such rational functions, what really happens is denominator can be 0. That gives you a vertical asymptote and a restriction on the domain, right? So this portion here, which is cx plus d, that cannot be equal to 0. That means cx is not equal to minus d, or x is not equal to minus d by c. That is the restriction. So that really means that x belongs to real numbers where x is not equal to minus d over c. Makes sense? Do you see how easily we got the domain of this function? And that is a vertical asymptote. Perfect. Now let's look into range. Now in these functions, we notice that there is a horizontal asymptote. Now, if the degree of numerator and denominator is same, then the equation of horizontal asymptote is y equals to a over c. It is the ratio of leading coefficients if the degree of numerator and denominator are same. So these are few critical points which you learn while learning about the rational functions, correct? We are only utilizing that knowledge here to write down our solutions for domain and range. Perfect. So that clearly means that we have everything for y except for the horizontal asymptote, which is at a over c. Is that clear to you? Perfect. Now to practice, we have an example here. The function given to you is f of x equals to 2x minus 4 over 3x plus 6. I'd like you to pause the video, sketch this function, practice, write down domain and range. You can write other characteristics of this function also. We are basically looking into the characteristics of functions, right? In case you really want to learn in depth, you can always contact me on this email. Perfect. Now coming back to our domain and range, clearly the domain here is that x is not equal to, when is the denominator 0? Where is the vertical asymptote? At minus 6 by 3, correct? So minus 6 by 3 means minus 2. And as far as the y value is concerned, it should not be equal to the ratio of 2 and 3. You get the idea, right? See how simple this is. And here is the graph of the function for your reference. Do you see that? So we have a horizontal asymptote, which is y equals to 2 over 3, and we have a vertical asymptote, which is x equals to minus 2, which is our restriction. You get the idea. So these are the two restrictions, as you can very clearly see in the example provided. So these examples work hand in hand to our learnings, and that is, I think, the beauty of this particular video. Now let's take up the next function, which is trigonometric functions. Now some students might not have done trigonometric functions yet, but it is soon to come, so we just can't avoid it. Now there are a couple of formulae which you should know while working with trigonometric functions. One of them is sine a plus b is equal to sine a cos b plus cos a sine b. Now, if I put both a and b as equal to x, then what happens? I get sine of x plus x equals to sine x cos x plus cos x sine x. Perfect. Which is as good as writing 2 sine x cos x. So as you can see, these two terms are exactly same. X plus x is 2x. So we get sine 2x formula here. So what do you notice here? I have purposely written the function as f of x equals to 2 times a times sine x cos x, correct? So you can see this as a times, thing like this, 2 sine x cos x, correct? And that means a, and that is sine 2x, double angle formula. Now if you have a sine function, the maximum value of sine can only be 1, minimum minus 1, times a, perfect. And therefore, we have the domain range of this particular function. Can you write down the domain range now? Well, as far as the domain is concerned, it is x belongs to real numbers, right? No problems at all. As far as the range is concerned, let me write it in the short form. Maximum value will be multiplied by a minimum also by a. So it will be from minus a. So that is the range, right? The y value, correct? To plus a. You get the idea. So for 2a times sin x cos x, that is going to be the range. Perfect. You can see the graph here. So the maximum value here, since the function is given to us as what? 6 sin x cos x. Do you see that? Now 6 can be written as 2 times 3 sin x cos x. So 3 is your plus and minus range for the function. Does that make sense, right? So easy now. Perfect. Very good. So let's now continue with another very interesting question, which is f of x square root of r square minus x square plus d, where r is greater than 0, right? Now, this is a semicircle. So some of you must remember x square plus y square is r square, correct? So we can now isolate y. And so taking x square to this side and then square root. Now we are only taking the positive values since, otherwise it is not a function, right? So therefore, we have a positive value. Let me rewrite the function. F of x as equals to square root of r square minus x square plus d, and r is greater than 0. Okay. Now, how do you write domain range of this? So the thing is that within the radical sign, we should always have non-negative number. And that is to say that r square minus x square should be greater than equal to 0, right? It can be equal to 0. Perfect. And that means that r square is greater than equal to x square, and that means r is greater than equal to square root of x square, which is absolute value of x, right? And that means that absolute value of x is less than r, or x is greater than minus r but less than plus r. Correct. So that is how it should be. So here we have an example for you, a test question, which is square root of 9 minus x square minus 1. I'd like you to pause the video and write down domain and range for this particular function. And for your benefit, I've also sketched this function along with some very critical points. That helps. You get the idea. Perfect. So basically, plus minus 3 is the domain, right? And so the x value has to be between minus 3 and plus 3. And the y values are less than and between 2 and minus 1, right? So the y values are from minus 1 to 2, correct? As you can see, and work it out. So I'd like you to work on this particular example. And now let's move on to exponential functions. Now, these trigonometric functions, exponential and logarithmic functions, are taken up slightly later. How? They're sure to come. Perfect. I have many videos on these functions. This one, I thought I'll make with general expressions so that any question thrown at you on this could be answered, right? So try to understand these concepts, and you can actually watch many of my videos on these topics. So we have taken a function, exponential function, a times b to the power of x minus p plus q. So you must have realized by now that major part of domain and range is mainly because of the translations, right? P and q. So it is the translations which change, right? So as you can see from here, if you have an exponential function, generally, let's say we have 2 to the power of x, right? Let's try to understand this exponential function, right? So let's say we have 2 to the power of x. In that case, we know that domain is all real numbers, right? So x belongs to real numbers. That is not an issue. The problem is on the range part, since we have a horizontal asymptote, right? So as far as y is concerned, it is always greater than 0 for the main function. But now what happens when we look into a translated function? Now, key part is played by q. So basically, the value of this translation will be, if a is greater than 0, right? That means it is going upwards. In that case, y will be greater than q, right? Because those are the translations going up or down, right? But if a is less than 0, then y will be less than q. So most of the cases, you have to look at this vertical stretch, and sometimes it is negative. That means a reflection on the x-axis. So it just puts it on the other side. You get the idea. Perfect? Okay, great. Now here is a test question for you on exponential functions. We have the functions. Let me write down, big and bold. F of x is equal to 2 to the power of x minus 2 plus 1, right? So you can write down domain range for this particular function. Clear? So here is the last one looking into, and then we'll review what we have learned in this particular video. Perfect. I hope you've liked it, right? F of x is log of x minus a plus b. Now, exactly similar rules are being followed. Log functions, for the benefit of some students, let me say, will look like this, right? Perfect. So this is normally at 1, and we have a vertical asymptote here, right? So in this case, domain is restricted. So x is greater than 0, but as far as y is concerned, it is belonging to all real numbers. But if you have a transformed function, then things change, right? So if I have this as my function, in that case, what happens? Well, x minus a in this case will mean that the domain x is now greater than a, because you have shifted a units to the right. As far as the y values is concerned, they will still be belonging to all real numbers. Makes sense? So based on this knowledge, we have another question for you, which is f of x is log of x minus 1 plus 2. Perfect. So that is how we have, and the graph for the same is also given to you to verify your results. Perfect. Now here is a test question for you on logarithms, and this is, what is the domain and range for, right? Domain and range for y equals to log of x squared. Okay, log of x squared. So I made it very simple, right? Just domain range of log of x squared. Perfect. So that becomes your test question. Let's move on to our learnings from this particular video. Very beautifully made video, right? I hope you appreciate that part at least. So we have looked into quadratic function, square root function, rational function, trigonometric function, semicircle, exponential, logarithmic, and composition of function. That is going to come next, right? So I hope you understand and appreciate what we have done here. And thorough knowledge of functions and their characteristics is kind of essential to move forward with prerequisites for calculus. In case you want to learn from me, you can always send an email or contact us on the website. Great. Thanks for your time and all the best.